Cool. For today's schedule, we actually have cool demo-like things. I don't know if perhaps Alvaro, our collaborator from Cal State, wants to introduce two of the students, Gregory Litman-Navarro and Ruben Bramasco, who have been working on adding cool new functionality to PrairieLearn. Alvaro, you want to sort of give a little bit of overview and then maybe turn it over to the students?
Yeah. So the work that you're about to see was meant for a database class where much of the course is about designing database models. We happen to use UML class diagrams, and our local version of a relational model diagram. You're probably used to some standard or somewhat standard diagrams for both of those. Well, UML is certainly a standard, but for the relational database, there are different versions out there, but we have our own local version, which we like and we've been using for a number of years. Our exams, quizzes, homeworks tend to ask questions to have students design a UML class diagram or take a UML class diagram and then implement it in the relational database. So all those kinds of questions that are traditional of database classes. So clearly they need to draw diagrams. So we needed that in PrairieLearn. We needed to have questions that present diagrams and which also have the students design diagrams for a given prompt of a question. All of that, of course, with randomization, right? So that no two students are getting the same version of a question. So PL does have drawing features, custom elements that you can have, but we felt that it wasn't enough. We needed to design our own. And Ruben is actually the first one to pick up on that work. So Ruben's been the one that's done the bulk of the work on the custom, actually building the custom elements themselves, and also using them to create questions. And then Gregory will show the use of Ruben's work in generating diagrams. So the students are not going to build the diagrams, but the diagrams themselves are built using Ruben's work. All of it dynamic, of course. So with that, I think Ruben will start off and then pass it on to Gregory after that.
Awesome. First of all, it's really nice to be here and nice to meet you all. The first time I attend one of these meetings, so pretty excited. I'm also a little bit nervous because I'm presenting, but it's okay. So like Dr. Monge said, we set out to make a question where students are able to draw, and we can automatically grade them. This would improve the speed of grading for the professor, of course. He doesn't have to do that himself. So really quickly, I'm just going to share a slide that we made so you guys can contact us if you wish. Basically, and I'll just put a little GIF right there for some of the drawing elements that we've done. This is my email if you guys have any questions after the presentation, and feel free to message me for any questions you have. So when we set out to make these custom elements, the first thing we started to do was look at what was already there, and we came across like the drawing elements that PL already had, and we actually tried to make UML diagrams out of the elements that were already there. So what we did was we combined the rectangle, and then there's also a few other elements that were already here. You can see they're already pre-baked for you, right? But we found out that it doesn't really work for what we wanted to use. If you could imagine, we have a rectangle, then we'd have to draw a line through that rectangle, another line through it, and then a text on top of that. And that just becomes a big HTML mess, right? So what we decided to do is go with something that was very new in PrairieLearn. Just this past January, it became part of the main repository. It's called the extension API, right? So basically, they let you create a a custom drawing element, and you can do whatever you want with it. And this is all built on something called Fabric.js, right? So what we did was come up with questions like this. Basically, you can drag them around, and they also like snap to the grid and all this stuff. And all of these are dynamically created each variant, right? So for example, here we have a JSON file where all we have is the set of classes that we want. And it's also,
Ruben,
yeah. Oh, it's not sharing.
Yep.
Sorry about that. Okay, good. Yeah, awesome. All right, so here we have in a JSON file, and we have the classes that are going to be dynamically created, and then also the answer, basically, right? Student enrolls in class, and this is the constraints that we have to it, right? So it basically goes through the question, and then it goes through the HTML, which I'll show you really quickly. And you can draw them, giving it like a left position, the top position, basically X and Y. You could also give them the height and width and dynamically assign the class name, right? So once that's all drawn out, you can now interact with it. The problem that we had before is we were able to draw these out using the very regular PL elements that were already there, but they weren't really user-friendly. You couldn't move them around. You couldn't do anything with them. One of the things that we wanted to do is make this thing really user-friendly, right? So we wanted to add things like snapping, like a line should snap to the UML, right? And it should also show you that it is snapped. As you can see, when I get close to it, it's kind of like gives you an indication that it is snapped, right? That's one thing that was really important to us, is to make the user experience really, just make it user-friendly, right? One other thing that we did is if you move the element, the line should also follow, right? That's something that we found that we ran into we ran into a lot of issue with, is once it was all drawn out, if a student makes a mistake, then they have to redraw the entire thing, right? So we put a lot of emphasis on trying to make the user experience really well, right? So we also have the grader that basically, once this is submitted, and I'll just really quickly, I have the answer right here. So the student class, I'm gonna put a wrong answer and then a right answer. Give me 1 second. And you can draw them pretty, or you don't have to draw them pretty. As long as they're connected, it's fine, right? So let's do, oh, that's not the wrong one. 0. Oh yeah, also the constraints are also snapped together there.
Hey, Ruben, I have a question.
Yeah.
This is really cool, by the way. Is it possible for the lines connecting the boxes to have any sort of arrowheads or anything like that on either end?
Yeah, so that's actually something that we were working on as well. It is possible. We had a working version earlier, but I kind of scrapped it to basically kind of rework it. It wasn't working the way I wanted to. But yeah, you can interchange any of those ends. You could actually interchange any of these points if you really wanted to. But yeah.
And keep going, Ruben. We also had plans to do aggregation, composition, and so on. So
right.
That's to address the point of the, what you can do at the endpoints. But yeah, all of that can be customized.
Yeah. Okay, so now saving grade. Hopefully it doesn't break, right? So I have some debug stuff right here. Forgot to take out, sorry about that. But you can see here, it was 50% correct. It was faculty is not supposed to connect to student, it's supposed to go to class. So now if student makes a mistake, instead of redrawing the entire thing, they can really easily drag this over here. If they want, they can fix their constraint, make it a little more pretty, save and grade, and this should give me 100%. There you go, 100%, right? The other thing that we were working on in the database course, the one thing that was really important was the RDB classes, relational database classes. This is where a bulk of our development time went into. It's basically, we have all sorts of things. Like if you want to have a primary key on the title, you can do that. You can add keys as much as you want. You can connect these keys just like you would the UML. And one thing that I thought was really cool is that you can create a brand new scheme. So here's an attribute, a floating attribute. I might add another one. So here, I'm actually just gonna put a test one real quick. Sorry about that, guys. But here's I'm gonna create a scheme. So I'll snap these together. You get a little indication. It tells you to enter the name. I'm gonna do this as the test. So now it behaves exactly like the other schemes on the canvas. And I can add keys to it. If I move the schemes, I can move these around, right? I can connect these here to any point on the side. You could also, this example here, unlike the last one, it doesn't have a grid. You can disable that if you want. You can add them if you wish. And yeah, you can, just the same way it uses the constraints, it can, just like the last question pretty much. And then just really quickly, I'm going to show you one of the things that we did for parsing this information. Let me just save and grade this stuff real quick so I can kind of show you guys some of the stuff that it did. So here I kind of got there's a connection from the foreign key to the primary key from these two schemes. It's represented right here. In PL, it's basically, it sends back a big old JSON object to the grader, and you can just parse it the way you want. We chose to parse it pretty much by doing a series of classes. So you can see like everything inherits a drawing element. From here, you can create a key. You can test if keys are equal to each other, and a series of functions that help you grade. And I also added some enums for the constraints and for the key types. But pretty much the idea is draw them using the database JSON file we have. PL with the code that we wrote, turn that into elements. Have the student play with the elements. They get submitted. Then we go through a parser, which turns them into these objects, and then we grade them using these objects. So yeah, that's pretty much it for the demo side of stuff. Does anybody have any questions on this stuff?
This is really cool. I think my main question is, what would it take, like if, one of our other courses, we wanted to use the element and build some questions around it. So I'm hoping that the answer is something like, oh, there's a GitHub repo that anybody on the team can access, and it's got some example questions and some documentation of how to use the element. And are you planning to do a pull request to like big PrairieLearn to make the element part of their standard library or something? Because I think otherwise right now you have to sort of copy the element code into every course that wants to use it, because we're doing something like that too. Yeah, I don't think we had any plans of actually putting that into PrairieLearn, but I think we threw that idea around. I'm definitely open to it for sure. But I think right now, if you do go to the CCS 323, I did put some documentation on how to get started with these elements and how to create your own. It is a big learning curve, though. I gotta admit.
So a couple of things. Number one, Ruben graduated from Long Beach, and the reason his email says CPP.edu is because he's going to be a master's student at Cal Poly Pomona. So he's gonna stop work on the project at the end of July. So basically Friday. Is it Friday now? The following.
The following.
The following Friday. So he's got 2 more weeks. And we can certainly put together a sample with the code for the custom elements into the repository where you have the other examples.
Yeah, I was going to say
we could put it in there.
Because for one thing, most people don't have access to course repos except for their own courses.
Yep.
But I'm thinking like if there could be sort of a a canonical copy of it somewhere. And then those of us who don't want to get out of sync can use like Git submodules or something to point to that, rather than like copying the element code into the course.
Right.
But I certainly see a use case for this immediately, you know, in some of our courses. So I want to make sure before Ruben escapes that we get this into a format and a location that other people can pick it up and use it and improve on it. This is really cool.
Thank you.
Yeah. As far as doing a sort of a pull request to PL, I think the documentation would need, you know, we would need much more of it. We haven't approached them. I know Ruben's worked with them because he had a bunch of questions, especially when the extension for the custom elements was still in basically beta. It was in a branch. So he started working on this way back, you know, when in January, February, when it was still just a feature in a branch, and eventually got merged. But no, I mean, I happen to think that the work was really high quality. This is more than what I imagined, you know, we could have for drawing these diagrams. So yeah, kudos to Ruben for that.
Thank you. All right, guys, I'm gonna pass it off to Gregory.
Hi, thanks for having me here. My name's Greg, and I've been working on augmenting some of Ruben's element extensions so that we can automatically draw randomized diagrams to illustrate the relational model schema of simple contrived databases. And so, oh, I think I'm sharing the wrong screen. Sorry. There, okay. So this RQG, it generates diagrams with a 2 or 3 schema, and it kind of shows where we are in the process and demonstrates the 2 primary use cases for this feature. And those would be, you can put the drawing in the question panel as a prompt, or you can also put it in the answer options for a multiple choice or a checkbox style question. And so basically in the final version, which I'll be putting together later this week, there will be a UML diagram in the question panel, and the test taker will have to, you know, select the correct RBD diagrams from the answer options. Yeah, so this will, so it grades and everything, and we can get a variety of variants generated here, different scheme names, scheme models and everything.
So when you're doing the new variant, what aspects of the question are sort of being randomized, and what aspects were hand authored at the time the question was written?
So yeah, I was going to go into the generate function here.
So just to make sure, if you go back, this is actually not a question. Greg is only using it to demonstrate the work, what he's been able to do. So but all the diagrams you're seeing here, he is dynamically generating. There is no input of any sort. The letters, which are meant to be the attributes, the constraints, all of that is a random choice. Greg? Correct?
Yeah, that's basically correct. Basically in the generate function, we have a few inputs. We wrote a class to create all the necessary data and to parse it into the dictionaries for the mustache template. So we give a few parameters to that, and that's basically the list of possible class names that we can use, as well as the dimensions of the canvas that we'll be drawing on. And then there's a set of other functions that we built there to generate the data and then put it into the forms needed for the schema. Let's see. And so yeah, that was, here's the class that we wrote to generate diagrams, and that is then passed into our template. So here in the question panel, just very much the same as what you saw before with Ruben's work.
Greg, do you have the question you need to implement, the one that displays the UML class diagram?
I do. I don't have
Can you
pulled up
show
right
that
now.
so that it makes it clear what we're?
Yes.
Yeah.
I'm not sure it's in this branch.
Okay.
Yeah, sorry about that.
But the idea, Armando, is to the question prompt would be a UML class diagram that has attributes. Like in this case, it would be a foo class and a bar class. And each of those would have attributes, single letters, random data type.
Okay, and then you're supposed to pick like which schema layout actually matches what the diagram is. Okay, that's cool.
And the UML class diagram is also randomly selected or dynamically and randomly chosen for the variant.
Okay, got it.
And then so are the options.
But the UML, the part of the code that deals with drawing the UML class diagrams can be used separately from the part of the code that I'm seeing here that draws the schemata, right?
Yes.
Because the UML class diagram stuff is also, there's a lot of things you can do with that even outside of a database context, right? Like we talk about design patterns and refactoring, and we use those diagrams all the time. So, okay, cool. Thank you.
Yeah.
Thank you.
Mm-hmm. Yeah, in fact, all of the custom drawing elements, there's no database really concepts anywhere in there. It's all about drawing UML class diagrams, lines, snapping them, that's all there is on the user interface and that experience. It's only the information about the question, whether it's design patterns or whether it's database, is in the question generator itself.
So in addition to the actual RQG that I just showed you, to accomplish this, we also needed to add a little bit of additional functionality to the custom PrairieLearn draw elements that Ruben made, so that the existing interactive features could be called programmatically by the RQG. And with these additional functions, we were able to automatically snap the primary and foreign keys, as well as the lines and the other constraints to our schema. And so the last thing that I just wanted to show you was just how easy it is to make a basic schema that just is already pre-drawn and everything. Right here, we have just basically 9 lines. We can make this this diagram right here, and don't have to futz around with any of the interactive components or anything. So just thought that was convenient and nice to have if somebody needed it. And that's basically all I have. Any questions?
Just my same one as before. Let's make sure we get this into a place where other people can easily see it, where there's some example questions that use it, and ideally some sort of documentation. But this is really great work, both of you. Thanks so much for your work on this.
Thank you.
Thanks.
So I think we have a repo called something examples, right? Which I can't remember what the exact name of it is, but it seems like that might not be a bad place to put the element code, as well as whatever documentation. In fact, I could probably, lead by example on that. We've been developing a custom element also for doing faded Parsons problems, and I've sort of created a little fake course just so that there's an elements directory that we can develop it in. But I think we're pretty close to where we can have a version of it that is sort of, suitable for others to use. So I just want to make sure that this work doesn't sort of get lost when the students wander away. There's a lot of really good effort here.
Yeah, there really is. Like I said, Ruben kind of hinted at the fact that there's a lot of complex issues having to do with the PL and fabric as well, that he had to kind of figure out. Early on, we were going in one direction, and it turned out to create a lot of work. Ruben, do you want to go into that a little bit? Just because we were, if you know about PL and especially some of the custom elements, some of the elements they already have, the way they get auto-graded is by how close the student is based on number of pixels to the target position of the answer, right? So especially when you're looking at some of those physics questions where there, you know, there's a spring or there's an object and it's gonna, a force is applied to it, where does it end up, kind of a thing, right? So they have to kind of say, okay, it ends up here. And they have to be within certain number of pixels offset
Right.
of
'Cause
that
they're
answer.
actually representing a physical system as
To
opposed
get
to
it
just like a
right.
logical diagram of something.
Yeah.
Oh.
So initially we were headed in that direction, and it got pretty messy. And then it was Ruben who kind of, you know, got the idea and eventually ended up with what we have. So Ruben, do you want to kind of show them that if we have time? Right.
Yeah, I think, give me 1 second. Yeah, I can show basically what gets compiled at the very end when the student hits save and grade. I think that kind of shows what's going on. Give me 1 second. Yeah. Share my screen. So there's like some of the data that gets sent in. Here, for example, this is from here to here. This is the data that needs to be either used during the user interaction or needs to be sent over to the actual grader, right? So for example, there's like a transform relation, right? This holds an ID. It's basically a list that holds an ID and then also some coordinates for the key, right? This is what allows the key to move with the scheme, right? So it's in a certain position and it needs, when the scheme moves, it moves, it needs to keep, basically it needs to tell the key, like you need to move also, but you're always gonna be this distance away, right? And then there's a few other things like the attributes data, like this is the one that I've typed in, the tests, and all this data just gets sent back. And at the very end, we parse it, right? But basically it all works off of IDs. So if two elements are going to talk to each other, they're going to do so through IDs. They'll, if a key wants to snap to a scheme, it'll say, is there any schemes around this area? And then the ID of the scheme will pop up and then it'll hold on to it and it'll move, and they'll just know about each other through IDs. And anytime one gets deleted, it updates the ID and so on and so forth. There's a lot of stuff to keep these in order, but that's essentially what it is. Keep track of the other's ID, and yeah. I think that hopefully that clears some stuff up. I don't know.
Yeah, so basically what we ended up with for our use, it doesn't matter where the classes and the lines are. That's not what matters. What matters is, you know, which endpoint, which class is connected to one endpoint.
Right.
And so all we need is the ID of that class and the ID of the line. And what's at the other endpoint? Oh, the other endpoint, we have this ID. And by the ID, we can look up which class it is. And now we can say, well, are these classes supposed to be connected together?
Right.
If they are, they get some points. If they're not, then we know by that.
So this is the line that was connected. So this would be right here would be like basically it's connected to ID 12 and ID 11. Here it has a constraint. One of the lines doesn't. One of the endpoint doesn't have the constraint because it's null, and the other endpoint has a constraint of 16. It also has exactly where they're snapped, like the indices of where they're snapped. Like so, for example, there's 0 and 1. So down here, oh, there's the wrong right here. So like it just basically translates everything over. But there's different points of where it can be snapped, and all this stuff is just keeping track of IDs pretty much.
Mm-hmm.
Yeah.
So for anybody who kind of goes into perhaps developing their own custom elements, that's something to consider, that the XY coordinates might not be actually what you want to work with. Instead, you want to work with the IDs of the objects, and you know what objects are contained inside another object just based on their IDs.
Mm.
Cool. Well, yeah, I mean, like I said, my high order bit is I want to use these and I want to make sure that the knowledge of how to use them and, you know, having a couple of example questions around them doesn't get lost. So can we agree on some sort of action plan for doing that, even if it's just initially kind of making sure that everything in the repos that y'all have been working in gets copied into the example course repo?
Mhm. Yep. Yeah, we'll take that on to make sure that all the custom drawing element work, as well as samples of how to use them, and documentation goes into the example repository, example course repository. Mhm.
Nice. Cool. Well, again, thanks for the work. Thanks for the demos. I look forward to having that stuff pushed into the example course repo. Is there any other stuff? I suppose I could stop recording for the moment.